In this first lecture video, I'd like to show you a game called Ken. It is a math puzzle type game that uses arithmetic. It is the richest in ideas of any math game I've ever played, and I've played a lot of them. So I'll let you take a look at the rules. Get to choose a grid size. We're going to choose 4 by 4. That means we got to use the numbers 1, 2, 4 in each row and each column. You cannot repeat a number in any row or any column. There's cages. I think you'll understand about the cages. You can read the rest of these directions if you want to. But let's get started. So here they are saying that the number 1 goes here. So that's all there is to that. The number 3 goes here. That's all there is to that. And now we've got to start filling in some other cages. Let's look at this cage here in the top left-hand corner. It adds to 7. That means the numbers in here, which have to be 1, 2, 3, or 4, and they can't be 2 of the same kind because these are in the same column, they have to add up to 7. Well, there's only one way to do that. That's with 3 and 4. Why can't we use 2 and 5? Well, there's no 5s in a 1 by 4 grid. So we've got to use 3 and 4, but the 3 can't go on top, because then we'd have a couple of 3s in the top row. So kind of by the process of elimination, some logical thinking, we get this. Now, what else could we do? Well, it looks like these have to be 1 or 2, but there's no real good reason, we think, to know which is which. Could a 1 go here, a 2 here, a 2 here, a 1 here? It seems all very reasonable. But assume for a second that a 2 goes here. Then to add up to 5, that would put a 3 here, but there's already a 3 in that column. So this cannot be a 2. Therefore, this is a 2 and this is a 1. 2 plus 1 is 3. 1 plus 4, I've kind of worked myself out there. 1 plus 4 is 5. This is a 1, 3, 4. This is missing a 2. With subtraction, it can be in either order. You're always doing big take away small. So it might seem wrong for you to think that this is going to be a 4 because you're thinking 2 take away 4 is negative 2. But with a subtraction cage, you subtract big take away small always. So this could be a 0 or a 4, but we can't use a 0, so we have to use a 4. So what else do we have? Well, 12 can only be 3 times 4 because 6 times 2 doesn't work since there's no 6s in a 4 by 4 Ken grid. So we've got 4 and 3. The 4 can't be here. So this has to be the 3 and this has to be the 4. And let's see here. This has to be a 2, then this has to be a 1 because this is division. And again, it doesn't matter which one comes first. It's big divided by small. So this could be a 4 because 4 divided by 2 is 2, but that 4 prevents it. So this has to be a 1. That's the only thing left. Since we've got a 1 and a 4 in this column, this has to be 2 and 3. It has to be 3, then 2. So take a look at that for a second and see what you think. So let's try another puzzle. Let's try a medium 4 by 4. Let's go to 6 by 6 easy. So I'm going to make it a little bigger on the screen because I like it bigger. And let's see what we have in this easier 6 by 6. Well, this is just a 1 cell cage, or 1 cage cell. So that was pretty easy. This is a 4. That's pretty easy. This is a 5. And I think I've got all the onesies, and now what do we do? Well, here's some facts. It would have been true of a 4 by 4, but it's true of a 6 by 6. We can only use the numbers 1 through 6. We have to use 1 of each in each row and in each column. But the numbers 1 through 6 add up to 21. So that's a useful thing to remember. The numbers 1 through 6 add up to 21. So each row in each column has to add up to 21. Well, all right, so where do we start? Well, I'm not sure where we start, but look in the top left-hand corner at the 75. The way to get a 75 is 5 times 5 times 3. That's the prime factorization of 75. Now you might wonder, well, do I need a 5? Why can't I use a 10? Well, if you multiply 10 times something, it's going to end in 0, and this 75 doesn't end in 0. So we really do need a couple of 5s and a 3. There's no way else to do it. And the two 5s can't be in the same column, and they can't be in the same row. So if you think about that a while, you will probably correctly decide that the absolute only way to put a multiplication of 3 numbers that gives you 75 is this. There's no other choice, and that's a pretty nice little thing. I sort of like that. So now, where do we know a lot of stuff? Well, we know a lot of stuff in this top row. Specifically, we know we've got a 3, 4, 5, so we need a 1, 2, 6. These have to divide to make 2, so if one of these is a 6, the other one has to be a 3, because 6 divided by 3 is 2, but the 3 is already there, so neither of these can be a 6, so this one has to be a 6. 6 divided by something is 3, that something is 2. This will be a 1 and a 2, but I can't see any reason for one or the other right now, so I'm going to avoid that and go over here to the first column. The first column, I know 3 of the 6 numbers, so that gives me some hope. My numbers are 1, 2, and 4. So let's figure out where the 4 is going to be. If the 4 was here, then this would have to be a 1 because 4 plus 1 is 5. But we've already got a 1 there, so this can't be 4. That means one of these two is 4. That means the other one of them is 2, because 4 divided by 2 is 2. And that means this has to be the 1, which means this is 4. Now I'd like you to take a look at the puzzle for a minute. You might think, well, I should try guessing somewhere. I should guess that this is going to be a 2 and a 5, or a 5 and a 2, or something like that. But let's not guess. Let's try a few strategies. Remember when I said each row and each column in a 6 by 6 has to add up to 21? Because 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. Well, this is 8 of them. So that means this is 13 of them, but that's 10 of the 13, so this is definitely a 3. So that these will all add up to 21. If this is a 3 and the subtraction is going to be 3, then this better be 6. So we can use those kinds of ideas fairly regularly. Now let's come down here to this 7, things that add up to 7. Well, it could be 1 plus 6, but the 6 prevents that. It could be 2 plus 5, but it can't be 2 plus 5 because this 2 means this can't be 2, and this 5 means this can't be 5. So you can't put a 2, 5, you can't put a 5, 2. The only other way to get 7 is 3 and 4. The 4 cannot be here, so that means the 4 must be here, and the 3 must be here. This is the kind of way that you do these puzzles. Notice this 4 prevents this from being a 4. There has to be a 4 somewhere in this row. There has to be one of each kind of number, so this is going to be a 4, and this is going to be a 6. That's how this thing goes. So now think a little bit. 5 has to be in 20 because it can't be 10 times 2. There's no 10s. So it's 5 times 4. This 4 prevents this from being a 4. So this is 4, and this is 5. All different kinds of strategies here, but notice that there's a 4 that needs to be in this first column. This cannot be a 4 because of this 4. So this has to be a 4. Now I'm getting the feeling like I'm doing cleanup on this problem, that if I'm careful, I should just win. There doesn't seem to be a whole lot left, really. So this could be 6 and 2. 6 divided by 2 is 3, or 3 and 1. It cannot be 6 and 2 because of this 2, so therefore it's 3 and 1. 1, 2, 3, 4, 5. This is 6 missing in this row. 6 divided by 2 is 3. We have 1, 2, 4, 5, 6, so this is a 3. 3 divided by 1 is 3, so this is a 1 for lots of reasons. So look for a minute. What do you think we ought to do next if I gave you time? We know quite a bit in this row. This is 3, 2 or 2, 3, but this 3 prevents this from being a 3, so it's a 2, 3. 1, 2, 3, 4, 6. This has to be a 5 because it's the only thing left in the column. We have 5 times 12. It's either going to be a 3 times 4 or a 2 times 6. But it can't be a 3, 4. It's got to be a 2, 6. So the 6 can't be here. So this is 2. This is 6. Up here, this has to be a 1 and a 2. But this 2 prevents this from being a 2. So this is the 2 and this is the 1. I bet you could predict what's going to happen down here. This has to be a 1. And this has to be a 5 for 2 reasons. 5 is missing in this column and 5 is missing in this row. When you get down to the end and it works both directions, you can feel fairly confident. Now let me... Yeah, so we've done another KenKen. What should you do? Well, one of our tests will have a KenKen on it, and you should be able to do a KenKen. A 4x4 is the goal for the test, unless it's extra credit. If it's extra credit, it might be a 6x6. If it's on the final exam, if a KenKen is on the final exam, it will be a 4x4, unless it's extra credit on the final exam, in which case it would be a 6x6. So there's a KenKen. There will be one of them in your book assignment, and I believe it's your first book assignment. You can check. I forget which it is right now. But you should do that along with your other book problems and turn it in on that single PDF file that's done in order. It should be at the end of that file.